Good morning to you. We had introduced the concept of architecture in the last session. You will notice that there are more slides provided than what is covered in the class. You are expected to go through the slides in conjunction with the textbook. You are also expected to watch the pre-recorded lectures as they form a very important component of the course. Today we understand quality attributes. Module 2, this is the contact session number 2, and I have a number of slides. I'm calling the first slide L1. This is what we cover under L1. Architecture and the type of requirements that we have under architecture, functionality, quality consideration, specific quality attributes, how you achieve them, and guiding quality decisions. Now, let's start from the very beginning, a very good place to start. When you set up a software system, you will have requirements. Requirements will come from stakeholders. These requirements can broadly be categorized into 3 categories: functional, quality, and constraints. Functional requirements are basically the use case stories as to how the system will function. What will happen, which button you click before which other button, what happens if you click a button, what screens will appear, what information will be provided. Now, things like this constitute the functional requirements. Systems have to be designed as per functional requirements. The stakeholders have to explain the requirement. Question answers I will not be able to take today. I will allow you to put them down in the chat session. I will try to cover some of them in tomorrow's session. We have a session tomorrow as well. So whatever questions I addressed over here, I'll look at them either tomorrow or after 2 weeks. We don't have a class next week. So the week after that, I'll be looking at the questions. So as far as coverage is concerned, please go exactly as per the course handout. If the mapping to the chapters is inadequate, I will try to supplement it. I will check it out from the course handout whether an adequate mapping to the chapters has been done or not. So this is as far as functional requirement is concerned. The next thing is quality requirement. The same system can cost an enormous amount more than alternative 1. You may have the same system being offered by multiple vendors, and the cost of delivery could be totally different from one another. What differentiates system A from B is the quality attributes, the requirements, and achieving the requirements. Now, software architecture, as I mentioned last time, is all about quality attribute requirements. And basically the job of an architect is to achieve the quality attribute requirements. The functional requirements is not the important thing. So it is not quality requirements that are achieved by functionalities. So the various vendors, okay, people are saying keep the mic close, and some people are saying it's coming loud and clear. So while I've been here, people are asking about the examination. Let me tell you, I'm not going to be able to address any questions regarding examinations just now because we want to move with the course. So I recommend that you go through the course handout, which is adequately clear on this matter. There will be review sessions before the examinations where we will clarify those doubts. So the third category of requirements is about constraints. The stakeholders sometimes talk about constraints that they impose. They will tell you use any RDBMS you like as long as it is Oracle. They tell you that we would like to have the database available locally. They will tell you that we are not willing to place certain data on the cloud. Well, you can try convincing them, but that's a decision that they've taken. So this sort of things are called constraints, and an architect has to bear these constraints in mind. So we have a three-pronged requirement. We've got functions, we've got quality attributes, and we've got constraints. Look at this IEEE 42010 2011. A little bit of close view on this would be helpful. To start with, you have a system of interest. You're developing a system. Okay, say you have been asked to develop the flying system for Boeing 777. So that is a system that is required. Then there's a request to zoom in. So here I go. So system of interest is here. This is the system, a flight system for Boeing 777. Now, the moment you have a system, you will have an architecture. The architect will think of the architecture, but there will be an architecture. Whether or not it is documented, whether it is good or bad, what it achieves is another matter, but there is an architecture. If there is a system, there's an architecture. And where there's an architecture and where there's a system, there'll be stakeholders. Stakeholders are people who have interest in the system. Who are the stakeholders? We've discussed in the previous sessions. They are the developers, they are the designers, they are the architects, they are the people who maintain, they are the people who use, they are the people who pay the money for the development, they are the people who will be marketing the system that will be produced. There will be people who will be actually using the system, the operators. We call them the users, the actual users. So all these people constitute stakeholders of a system. And then you have to have an architecture description. For various purposes, a description is required. We have discussed it in the previous session, but well, let's take it. You require a description. The description of the architecture expresses the architecture. Okay, a photograph of my student, say I've got a student here called Sunil. So Sunil exists whether or not a photograph of his exists. Sunil exists whether or not a biography has been written on him. But say information about him is required by BITS Pilani. So they create a profile, a description. They call it a student description. It contains essential information about him: home address, email ID, telephone number, qualifications possessed, where he's working, how many years of experience he's got. So this is the type of description of a person. Similarly, an architecture has a description, and we will see more of how to describe an architecture as we get along. The description of the architecture consists of the rationale as to why you have this particular architecture, the logic behind having the architecture. You will have a lot of correspondence regarding the architecture and the rules which will determine the architecture. So these sort of things would exist. Now, to describe the architecture, we will have a number of views, and views are something which we have mentioned in the previous sessions, but we'll go into more details later. Structures views, component connector views, allocation view. So various views of architectures will be there. So stakeholders, they have an interest in the system, and because of their interest, they have got certain concerns. The maintenance people would like to make sure that the system can be maintained without or with a minimum of downtime. The developers may be interested that the system should not become too complicated to develop. The amount of effort involved should be commensurate with the amount to be spent on the system. So there are viewpoints. So the concerns are placed in the form of viewpoints, and the viewpoints are governed by the views. So there are various viewpoints of an architecture. So like we talked about physiology, the orthopedic is only interested in the structural view. So that's the viewpoint. So the orthopedic view, the structure of a human body would be a particular view of the human body. Similarly, if there's an architecture, you may have the component and connector view on a particular type of view. You may have a module breakdown view. So this viewpoint is of interest, and it constitutes a part of the description. Correspondence, let me repeat once, it is the communication between stakeholders, between the architect and the stakeholders. What stakeholders convey, what is conveyed to stakeholders. It could be in the form of emails, could be written documents, could be study reports, could be a system requirement specification that has been drawn out. So these are correspondence, and there are certain rules governing the flow of communication, the way correspondence will be archived. There are some companies which have formal archives for correspondence. They have rules, how these are archived and documented. So these will be the rules that determine correspondence. Let's go further down. Now, these viewpoints are reflected through models, and various models, types of models can be there, and against each type of model there will be specific architectural models that will be available, standard architectures, and based on these standard architectures you will determine views, which will determine descriptions, which in turn will determine the architecture. So you may start with a stakeholder, you can talk about his concerns, there are viewpoints that are presented to him based on kinds of models, you select particular models. These particular modules are reflected by certain views which constitute a part of the description, and this description reflects the architecture that will eventually be developed. So this is how we talk about it. Let's move forward. Okay. There's a question here, says that what has correspondence got to do with description? Well, a lot of description is communicated through correspondence, which may eventually get documented in an architectural documentation. But correspondence does convey the requirements of the stakeholders. It conveys the architect's decisions as to how those concerns are being addressed, and we'll be going into great detail. We'll be having classes, sessions over here, and you have material available as to how we'll be taking these into concern. So these are the physical aspects where the architect is now getting involved. These are peripheral items, and these are core architectural issues which are there inside the dotted boxes. The notation here, let's not give too much importance to it. Those of you who have done any UML diagramming would be aware of it. A lot of UML notation education is going to take place in OAD. So by the time we reach the midterm examination, we will compare notes. Okay. Relevant question: the relation between architectural description and views. Say, I will again take a human being, a student here. Let's say student named Kavita. So Kavita can be described. So let us say that there are various people who are interested in Kavita. Her mother, maybe her father, her friends, her teacher. There are various people who have interest in her, and they see Kavita in a different viewpoint. She is a friend to people. She may be a sports person. She may be a student. She may be a IT worker. So every person has a different interest, and that different aspect of Kavita is the actual architecture of Kavita. Whether or not she can be fully described is dependent on the capability of the people who are describing. There was a recent movie named Sanju, cast on the life of a particular film star. Now, whether or not the movie describes his life correctly or not could be an object of controversy, could be a point of view, but well, that is a description. Now, how did you describe that person? That person, yeah, the characteristics of that person, Kavita, is definitely the architecture. So similarly, the characteristics of the software is the architecture may or may not be properly described. It is totally dependent on how good my students are at the end of the course, that they are capable of describing a particular architecture. They are capable of putting it into paper and say that, yes, this is the architecture. Now, to express the architecture, there are various tools available. In the case of Sanju, you a complete film, which is a video depiction. There could be photographs. There could be newspaper reports. There could be correspondence. There could be legal documents available with the court. So all these things went to describe this person. One of the methods of describing are various views. There are certain views which none of us have seen of Sanju. There could be an X-ray showing his structure. So any injury he has suffered might be depicted on his bone somewhere. His neural system might give some depiction of his mental states. His circulatory system at a particular point of time might give a report on the type of drugs that existed in his system. Similarly, architectural views, and we'll be going into more details later, consisting primarily in the categories of structural views, module views, component connector views, allocation views. These are views, these are methods of presenting an architecture. And naturally, if it's a method of presentation, it becomes a part of a description. Now, again, talk about model. There are various standard models which are available. Your company may be having certain architectural standards. If you are working in a large company which has got a very complicated website, they may be following certain architectural models, and they've taken a decision that this is how our website is going to be like. And what is the system of interest? That is the project itself. When I started this page, I said, let's say Boeing 777 is the architecture we are interested in. System of interest happens to be Sanjay Dutt. Okay, that is a system of interest. System of interest happens to be Kavita. System of interest happens to be a point of sale system. So somebody has probably just come from a class on object-oriented analysis and design, is talking about controllers. Let's not get bothered about creators, controllers, expert, cohesion, coupling. Let's allow these two courses to proceed parallelly. And since there's a lot of meeting of technology and a lot of meeting of jargon, we will touch base before the midterm exam. But I'm deliberately leaving a detailed study of UML to the other course. I'm not going to indulge very seriously into UML here, but let's say that you have to have a decent idea of UML. Okay, Again, there's a question, what is rational? What provoked me to go in for this architecture? What provoked me for going into this architecture? And we will see as we move around that it will be quality attributes. To achieve this quality, I want you to do it this way. So model kinds, there are a number of architecture models, and they naturally belong to groups. They are kinds of models. So I think we need to move on from here. Okay, functionality is ability to do work. Functionality, I had mentioned the dotted rectangles are the core concerns for us in this course, architecture. The architect is concerned about those parts inside the dotted rectangles. Functionality does not determine architecture. Functionality determines design, object-oriented analysis and design. Your relationship with functionality is much heavier in object-oriented analysis and design. There you'll be having your analysis models, design models, you'll get into those concerns. They will have some concern on quality attributes, but the main concern there will be functionality. So you can create functionalities, but quality attributes, they are like this. Quality attributes are absolutely orthogonal to functionality. Functionalities could be provided, and if you don't provide the quality attribute, you just may not get your payment. You're developing a software. It says, please give a software which will add two numbers. So you write a software, within 5 minutes you're ready. 2 plus 2 is equal to 4, 3 plus 5 is equal to 8. Work perfectly, you deliver the system. Person goes to run it, can't load it. It's not running in my operating system. Okay. The person who wants to operate it is sitting in the USA. I've delivered my software in India. It won't work. So what happened was that people forgot to indicate the quality attributes that the software was to achieve. And the language of quality attributes is what our concern in today's session is. We'll get into quality attributes in a little more detail. Orthogonal means right angles to each other. So functionality is one dimension, quality attributes is a totally different dimension. You can achieve functions without achieving quality attributes, and vice versa. You can talk about quality, but functionality is required. So both of them are a part of system specifications, but we software architects are going to concern ourselves with quality attributes only. Our concern is quality attributes, not functionality. So you press this button, the options button appears. As an architect, I couldn't care. But I could care about how long it takes for that button to appear. If that button takes 5 minutes to appear, it's probably not a problem with the programming. The problem is architectural. Some architect has not taken care of concerns which are totally architectural in nature. So what would be the issues which would concern this dialog box appearing? So somebody here says that maybe the functionality was not well defined. Quality attribute description is not a part of functionality. Let's put it very clearly. Take this example itself. When the user presses the green button, the options dialog appears. Now tell me, what is wrong with this specification? It's very clear. So you press the green button. Any of you who have done any program in almost any programming language know it's just 2-3 lines of code. Whatever, there's a click event. Based on the click event, a dialog button is supposed to appear, and it's supposed to say blah, 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 blah. But then the issues of concern could be performance, availability, usability. Usability, do you notice the green button? Where is it? How big it is? Where on the screen is it? That is usability. What is performance? Performance is whatever system is this green button running on. What is the load on the system? I happen to use the same system for bulk mailing. And on that system being used for bulk mailing, I intend to press the green button and make an option button appear after looking up a database. The database is not being able to respond. Well, performance. Availability. When I go to click it, the CPU is not available. It's 100% occupied with other issues. So availability, performance, these are issues. So, and performance, availability, usability are not functional requirements. So being able to give a response in a certain time, being able to respond at all, or being how it appears on the screen are not functional requirements. These are quality requirements. Somebody says, what happens if code written behind the button appears? That's poor coding. It's got nothing to do with quality requirements, got nothing to do with functional requirements. That's simply poor coding. Okay. Now, these definitions provided for an attribute, we have got a lot of definitions. We'll talk here about availability, performance, we'll talk about usability, we'll talk about testability, modifiability. So each one of these, we've got to understand what this quality is about. Many of you may be already thinking that these are going to be vague arguments and vague statements. Mind you, every one of you belongs to the IT industry. Otherwise, you would not be registered in this course. Not obviously a course for educated unemployed or unemployed uneducated. This program is being offered to professionals. All of you are IT professionals. You know very well that if a client has a requirement, you've got to deliver against the requirement. If the requirement is vague, you cannot deliver. So it's time we put on our shoes and started thinking as to how quality requirements are to be stated. So somebody has clarified here that somewhere else they've heard of non-functional requirements. You've got a dot on, these quality requirements are called non-functional requirements. If anybody in a graduate level has done a course in software engineering, they would have come across this language called non-functional attributes. These are quality attributes. Now, somebody says, whatever it is, we want the software to be user-friendly. And then when you go and deliver, he says, no, this is not user-friendly. Now, who decides? Who's the umpire? So somebody says, no, we should have a system which will test user-friendliness. Okay, who will develop that system? No, we'll have a third-party umpire. So what will the third party do? When we finish all our work, he'll come and tell us that this is not user-friendly. And we don't get paid for all the effort done. So it doesn't work like that. So the community which works on quality, which delivers attributes, architects, they've developed their own vocabulary, their method of stating quality. And our quality will be stated in black and white, crystal clear, deliverable, so that when we deliver against a quality, we will promise against a quality, we will deliver against a quality. We will sort out with the stakeholders what exactly is required by the stakeholder, and we'll deliver exactly what is required. We'll ask for payment against each variation in the quality attribute. So it's not as if anything will cost the same amount of money. The client will be told, the stakeholder will be told, okay, this is what you're looking for, usability. This is the levels of usability that is possible. If you achieve this, this is the cost. If you achieve this, this is the cost. And then you will be discussing as the course proceeds that we will be having meetings with stakeholders. We'll thrash out the attributes, decide exactly what combination is to be delivered, and deliver. Okay. The way we deliver is something called a scenario. You'll be moving along in the course called OOAD, Object-Oriented Analysis and Design, where we will talk about use case texts, where you'll present various scenarios. Those scenarios are functional scenarios. The scenarios we talk about in this course are non-functional scenarios. You've got to understand it very clearly. You will have a use case diagram out there where you will say this is the list of scenarios. And in your question paper in software architecture, if you present those scenarios, you will get zonked out. This is not what you're looking for. If you're employed as a software architect and you give a whole lot of functional scenarios, they are not going to keep your job as a software architect alive. So here we talk about quality attribute scenarios, which are scenarios almost as good a scenario as any drama that you present, any scene. We will see in a while what a scenario looks like. A scenario has the following parts. The scenarios operate around an artifact. So, application consists of artifacts. This artifact could be a software system, it could be a hardware system, any particular component or module or submodule of interest to us, for which we are looking for a quality attribute. So, we have an interest in a particular quality attribute. And that quality attribute acts on a particular artifact, and this artifact exists in a particular environment. What could be environment? It could be a test environment, it could be a dev environment, it could be a step-down environment, an environment under overload, the various environments. The artifact could be the CPU, it could be a server. So these, I've started with the last two. There's an artifact in an environment. So we'll be talking about a quality attribute. Now, what is the quality attribute? Quality attribute: availability, performance, security, reliability. Reliability is again got to do with availability. Then we go into scalability. So testability, modifiability. So these are various quality attributes. So what do quality attributes achieve? Quality attributes allow the artifact to produce a response against a stimulus. Something happens, against that something else will happen. And what happens against how much of the response happens against what stimulus is what quality is all about. So if what response against what stimulus is what quality is all about, there's got to be a method to measure the response. Is environment and platform the same? The artifact and platform are the same. The platform can be an artifact in a particular scenario. Stimulus could be, we'll see a few examples of a stimulus. Stimulus is something against which the artifact has to respond. Now, every stimulus has to have a source. Okay, let's again take a very ordinary example to understand. There's somebody called Divya, who's my student over here. And Divya was stimulated by a presentation by the faculty. And because she was stimulated, the source of the stimulus was the faculty. The environment, God knows where Divya is sitting, could be in the drawing room, could be walking around with a mobile with earphones plugged in, could be sitting in a lecture hall with a whole lot of other colleagues listening to this lecture. But that's the environment, and the artifact is Divya. The response was to ask a question. The response measured could be, is this question important enough to answer immediately, or can it be answered later? Is the question difficult to answer, or is it easy? There are various ways, and that again we'll have to quantify it. So measurement has to be quantifiable, measurable, can be established, and we'll go in for examples on quality data. Let's take an example of the Google web page, the page that appears the moment you say google.com. That's an artifact working under what environment? Environment in your house with an internet connection over a lease line. Now, the stimulus is you ask for the meaning of software architecture. Source of the stimulus is the operator, the person using the system. Stimulus is an inquiry, what is software architecture? The response is Google shows you a page which describes software architecture, the first one being a small summary created by Google, thereafter something by Wiki. And then, how do you measure it? The response appears in 2 seconds. So, if the artifact is a platform, how does it respond to a stimulus? Well, the platform is, say you're talking about a hardware platform. The hardware platform may be running an operating system. The stimulus could be a request to send a communication to RAM. How quickly has it gone across? So individual measures we'll get into. I gave you an example just now which is on time. We'll have a lot of examples. Let's move on from here. So you've got to memorize this and know it by heart, that there's an artifact working in an environment which is activated by a stimulus from a given source. There will be a response, and the response has to be measured. And how we will measure is the level of expertise which we all need to develop. And we move on. I've explained these points. These are defined for your convenience. Well, somebody says, can you say stimulus is an input and a response is an output? Absolutely, I will have no problem if you thought of it that way. See, the point is that out here, we are talking about software systems, modules of software. But any effort to discuss software architecture is incomplete without involving hardware. Unfortunately, we cannot just wish away hardware while discussing software systems, because many of the solutions to our quality requirements actually come from hardware. Only thing is, we don't get involved in the design of hardware, we use hardware as a resource. Now, someone says, well, how is an artifact different from the source of stimulus? Okay, artifact is Navdeep, and the source of stimulus is the faculty. So the stimulus what happens is that the artifact is a car. The stimulus is a car coming from the other side. This car responds by moving off the road. You say the car didn't move off the road, the driver made it move. The driver is a part of the car subsystem. So when you talk about the artifact called the car, everything that was a part of the car, the driver, the engine, the software that drives the engine, everything is a part of the car system. So here again I am telling you that we cannot just wish away the hardware from the software. Things go together. When we talk about a server, the server has got to respond. The server becomes an artifact. Yes, a bug report. The bug may not be the stimulus, the bug report may be the stimulus. A bug reported by whom? It could be by the programmer himself, by the tester, by the actual user. So that could be the stimulus. The bug comes in, and the artifact could be a piece of software. You have written a program, and that is the artifact. Under what environment? It could be under dev. It could be under production. It could be actually a running system. Now, the response could be correction of the bug. In how much time? Within 2 hours. So you have to establish standards. You will have to say that, well, somebody says, can the developer be the artifact? I wonder. We'll have to think of an example where we make the developer an artifact. But as of now, I see a developer as could be a stimulus. He could be providing certain input which would require a response, and the response is measurable. So you may have to set standards that any bug report will be categorized into 5 levels, from casual to critical, Okay. Yes, you can call code as an artifact. You can have the architectural document could be an artifact. Any document, any piece of software could be an artifact. A running piece of code could be an artifact. Source code could be an artifact. An event can be a stimulus. Yes, an event can be a stimulus. Developer could be a stimulus. He may give you a bug report on a piece of code. A developer may provide the bug report, and the same developer or somebody else may have to attend to it, but the response will be that the bug has been attended to and the amount of time. It could be a real world object, it would be a piece of hardware with software. Everything would qualify as an artifact. Anything that we act on is an artifact. I think we've got a good number of examples that I've gone through. Incidentally, I'll be leaving a lot of work for you to do on today's session. Okay, so next 2 weeks you'll be extremely busy. You'll have to do a lot of reading to understand quality attributes. Those of you who are examination oriented and very keen on getting good scores, let me warn you that the level of knowledge that is required for an examination is going to be very small compared to the level of knowledge required to become a software architect. Fortunately for some, unfortunately for others, this course has got a huge content. In fact, the feedback I get at the end of the semester is that the course is too much for one semester. Well, the course is too much for one human being also, and software architect has to have a lot of stuff up there. Many of us who have architected systems have spent a lifetime on software architecture. You want to push it all into one semester and then be on a flying career from next semester. Naturally, you have to put in hard work. But as far as meeting the academic requirements of a course is concerned, not very difficult. And there are questions that keep coming to me where the answers are in the course handout. I'm not going to address again what is the textbook, what is the course for the midterm exam, what is the coverage today, what is the coverage in the next class, what should we be doing for our practical knowledge, which book should we read. Everything is there in the course handout. So I'm not going to even attempt to show it. In the previous session, I took you to the course handout and I showed it. You can go through the recording of the previous session to see the course handout, alternatively download it from eLearn. Now, let's get back here. We talk about a general quality attribute scenario. So I will spend some time on a general quality attribute scenario. I am not going to spend time with you all on individual quality attribute scenarios. Okay. The reason is that my colleague who has provided pre-recorded lectures has taken care of them in great detail in his presentations. Could be hours of listening, but you have to find the time. The textbook covers it beautifully, but I will cover the general scenario to give you an idea of what a scenario is about. This is what it looks like. I think by now you've already got a picture in your mind based on the verbal communication we've been having. You have an artifact, which could be a processor, a communication channel, storage device, processor, whatever. See, many of them, these are hardware units. So you may say, then why do we call it software architecture? Well, many of these have got software on it, and most of the response measure will be taken care of by appropriate use of software. Stimulus could be a fault, an omission, a crash, incorrect timing, incorrect response. The source could be internal or external. It could be from people, it could be from hardware, software, physical infrastructure, physical environment, etc. Response could be to prevent the fault. It could be to shut down the system, make the system unavailable. You could fix or mask the fault, or you can run the system under degraded mode. When the bank system is not working properly, they allow just a few essential features to continue working. How do you measure it? Timing, availability percentage, time in degraded mode, repair timing, and proportion of fault system, etc. I'll just pause it for a while. So yes, so this is a general depiction of a scenario. Very good question. Where's the environment? It's just not been shown here. It's somewhere above the artifact. In fact, all this is environment. The artifact acts in the environment, and in your answer, you have to give the environment. Maybe this diagram doesn't have it, but you'll have to always present the environment. Now, this is a very important component, and again, something which I'm not going to take up with you in the class: tactics. To achieve the correct response, we use tactics. Now, let's understand what a tactic is for those who may not be initiated into the world of tactics. We are in India, so I think we talk cricket because most of the world will be talking about football. So what happens is that the nation has a strategy. The strategy is to have cricketing bodies, to have associations, to have training centers, to have academies, so that you can train cricketers, to build up interest in cricketing. So that could be strategy. The strategy of the team would be to make sure that the players are given enough rest, make sure that they get certain grade of training, they get some international exposure. This could be the strategy. Tactics would be once you get into the match, depending on the score, what is the pace of scoring we will put in, what type of batsmen will put high up in the order, what type of batsmen will go lower, what type of bowlers will we engage for which batsmen, how will we put our bowlers through. This could be tactics which are taken care of the match level. Operations are the actual act of going and hitting sixers and fours and picking up wickets. Those are operations. Similarly, an architect has a strategy. The strategy is developed through architectural models, which may come through standard approaches taken for in certain industries, which help us to achieve good solutions. And that is why you often find architects belong to certain verticals. There's an architect who's worked in telecom. There's an architect who's working in aviation. There's architects who work in the banking and finance segment. So the reason being that these people develop specialized knowledge in particular areas of work, and they know the strategies that best fit into these areas. Then we have tactics, and the next few slides I've given a lot of tactics, but I will not be covering them in the session with you. My colleague has given a lot of lectures on tactics. The book covers it in a number of chapters. You'll have to go through these tactics, and from an examination point of view, and there are lots of people who would be very keen to hear that, you need to know every tactic that is given in the textbook. So for an architect to achieve the goals, and you should be able to pinpoint, okay, this is the goals, this is the tactic I suggest. It's almost like a doctor. He looks at the patient and investigates, and then says, okay, give some paracetamol, whatever it is. Okay, somebody says that when I talk about functionality, OAD, when I talk about quality software architecture, damn good, I like it. Okay, put it that way. But the point is, like everything else in life, there will be overlaps. We will be borrowing from a lot of OAD artifacts, and OAD will be borrowing from a little bit of software architecture. But broadly speaking, you got it absolutely dot on. We talk about functionalities in OAD, but even while we talk about functionalities there, they talk a lot about software quality out there. But quality at a macro scale is what we handle. Yes, we do have class tomorrow. That's a question that has come suddenly. And a totally different topic, not on quality. Now, we present a quality requirement through a scenario, and you will be studying scenarios for each quality attributes, and I'm giving you the slides. You'll find them uploaded in a day or two. Go through them. They will show you how to draw scenarios for various quality attributes. But out here, there are other decisions that architects take. Allocation of responsibility. There's somebody who hopes that the handout has been updated, is an updated one. I mentioned this even in the previous session. I do not understand what you say when you mean by updated. Please let me know exactly what you want me to update in that handout. Because you've got a course handout, the course handout is the course handout. And what is an updated course handout is beyond my comprehension, because I never promised an updated handout. And if you have a requirement for an updated handout, please let me know why you want it to be updated. Okay? There's a person who's asked, and this question had come last time also, and then somebody had said, sorry, he was talking about another course where the faculty had promised that the course handout will get updated. We are studying software architecture in this course, and I have not promised any updated handout. The handout you've got is the course handout. Does it satisfy your question, or is there some clarification you'd like to give? I'm not mentioning your name. Well, in the last class, the students saw a difference between the handout that I showed on the screen and the handout that he managed to download from eLearn. Well, this is a mystery, because when I presented the handout here, I actually went to the eLearn page, I downloaded it from there, and I opened it in Word. So there's absolutely no question. Oh yes, again you got the same thing. It is for another subject. Excellent, very good. Let's cut out other subjects from. Yeah, let's move on. Let's move on. Thank you, thank you. So let's stick to software architecture here. Okay. Allocation of responsibility, coordination, data model, management of resources, mapping among architectural elements, binding time decisions, and choice of technology. So I'm going to stop this recording here. We take a 5 minutes break. We get back after 5 minutes. I'll be discussing this in details. But let me tell you that I'm giving you all these slides: availability, interoperability, modifiability, performance, security, and there are two more: testability and usability, which I expect you to go through at home. So I will not be taking these up in detail in the session here, but I expect you to go through them. If necessary, I'll have a special session to help you out with questions. If I find there are lots of questions that are coming in, I will have a special session and take up your individual doubts in the sessions. Okay, so I'm stopping the recording and going in for a 5 minutes break. Please go and have tea, coffee, whatever, and get back within 5 minutes.